The water inside this comet may have frozen before the sun existed. And when it entered our solar system, a Harvard scientist asked whether it could be hostile alien technology. Those two claims sound like they belong in different stories. They do not. They both come from the same object, 3I/Atlas, the third confirmed visitor ever detected from another star system. The obvious question is whether it is a comet or a machine, but that is not the real mystery. The real mystery is why a completely natural comet can look this strange. On July 1st, 2025, the Atlas survey in Chile found a faint point of light moving through the outer solar system. At first it looked ordinary. Then, astronomers calculated its orbit. The line did not close. Planets, asteroids, and most comets travel around the sun on ellipses. They return. 3I/Atlas follows a hyperbola. It entered once, crossed the planetary system, and will leave forever. Its orbital eccentricity is about 6.14. Below 1 means a closed orbit. Exactly 1 is the escape boundary. Anything above 1 is unbound. 6.14 is not a borderline result. It is far beyond the line. Before the sun accelerated it, the object was already traveling at roughly 57 to 60 kilometers per second relative to the sun. That part is not controversial. 3I/Atlas came from interstellar space. But almost everything after that became an argument. Early images showed a fuzzy cloud around it. Astronomers call that cloud a coma. A coma forms when sunlight warms buried ice and releases gas and dust. That normally screams comet. But the same cloud hides the solid body inside it. A tiny nucleus wrapped in bright dust can look much larger than it really is. Hubble observations placed the nucleus radius somewhere between roughly 160 meters and 2.8 kilometers, depending on which volatile was driving the activity. That is the difference between a city block and a mountain. And that uncertainty opened the first door to controversy. Avi Loeb at Harvard argued that if the object were truly enormous, then the galaxy would need to contain an unexpectedly large mass of similar interstellar bodies. That mass budget question was legitimate, but the simpler answer was also obvious. Much of the brightness could be dust, not solid rock. Then the debate escalated. On July 16, 2025, Loeb, Adam Hibbard, and Adam Crowell released a paper titled, "Is the Interstellar Object 3I/Atlas Alien Technology?" The paper did not announce a discovery of alien technology. It described itself as largely a pedagogical exercise. But it argued that a technological origin should remain on the table, and it even used the phrase possibly hostile. That phrase traveled much farther than the paper's caveats. The authors pointed to the object's unusual geometry. Its path passed close to the plane in which the planets orbit. It approached the regions of Mars and Jupiter, and near perihelion, when it was closest to the Sun, Earth had a poor viewing angle. If the object were a probe, Loeb argued, those features might be useful. But there was a problem. The test was designed after the trajectory was already known. Imagine firing an arrow into a wall, then drawing the target around the place it landed. With enough angles, dates, distances, planets, and viewing positions to choose from, almost any unique orbit can be made to look statistically special. A rare geometry is worth studying. It is not evidence of intention by itself. And then the object became stranger for a completely different reason. Not because of its orbit, because of its chemistry. In August 2025, the James Webb Space Telescope observed 3I/Atlas, while it was still more than 3 astronomical units from the Sun. Webb detected a coma dominated by carbon dioxide. The carbon dioxide to water ratio was 8.0, plus or minus 1.0. That was extremely high compared with the usual trend among solar system comets. As the object moved closer and warmed, the chemistry changed. Carbon monoxide became dominant. Methane appeared from deeper layers. Methanol and hydrogen cyanide appeared in unusual proportions. This was not normal chemistry for the comets we know. But that sentence contains a trap. The comets we know formed around our Sun. 3. I/Atlas did not. An object born around another star should not be expected to match the average chemistry of our own planetary system. So the alien argument did not become stronger. The natural explanation became more interesting. Then Webb measured something far more revealing. In December 2025, it detected two forms of water in the coma. Ordinary water contains normal hydrogen. Heavy water contains deuterium, a heavier isotope with one proton and one neutron. The ratio between deuterium and hydrogen acts like a chemical fossil. It can preserve information about the temperature at which the water formed. For 3I/Atlas, the measured deuterium to hydrogen ratio was 0.98%, with an uncertainty of 0.06%. That is more than an order of magnitude above the values measured in known solar system comets. But Webb did not directly photograph a percentage inside the ice. Its spectrograph split infrared light into molecular fingerprints. Researchers measured emission from ordinary water and from HDO, water containing one deuterium atom. They used a model of the coma to convert the brightness of those spectral lines into molecular production rates. Then they compared the amount of HDO with the amount of ordinary water. The result points to water that formed below roughly 20 to 30 Kelvin. That is colder than minus 240 degrees Celsius. At those temperatures, reactions on dust grains can enrich water strongly in deuterium. But this is not a thermometer reading. It is a model-based inference. The models say that a ratio near 1% is easiest to produce and preserve when water forms in extreme cold and is not later diluted by large amounts of warmer, reprocessed water. And this is where the story stops being only about a comet. The hydrogen in your body was created near the beginning of the universe. The water you drink has been recycled through clouds, planets, oceans, rocks, and living cells. But the water in 3I/Atlas may have remained chemically marked by a place colder and older than anything that formed around our sun. When we measured that ratio, we were not just identifying ice. We were reading an environmental record from another star system. Then came the headline that the object could be 10 to 12 billion years old. That number requires care. The deuterium ratio alone does not date the comet. The age argument also depends on carbon isotopes. Webb measured unusually high ratios of carbon-12 to carbon-13 in carbon monoxide and carbon dioxide. Across cosmic time, generations of stars manufacture and spread heavier isotopes through the galaxy. Material with relatively little carbon-13 may therefore come from an older, more metal-poor environment. Researchers compared the measured ratios with models of galactic chemical evolution. Those comparisons suggested that the material may have formed in the early Milky Way, potentially 10 to 12 billion years ago. Potentially is the important word. This is not radioactive dating. There is no clock inside the comet showing 12 billion years. The orbit is directly measured. The molecules are directly detected. The formation, temperature, and age are interpretations built from chemical models. They may be strong interpretations. They are not the same thing as direct measurements. Meanwhile, the evidence for a natural comet kept accumulating. Hubble saw dust and a sunward fan. Mars orbiters watched the coma change. The European Space Agency's JUICE spacecraft detected gas and dust extending more than 5 million kilometers. The estimated water production reached roughly 2,000 kilograms per second. The object also showed small changes in motion consistent with thrust from outgassing. That matters. An unexplained acceleration without visible mass loss would be difficult to account for. Here, the object was visibly ejecting enormous amounts of material. A comet naturally pushes itself when gas escapes from its surface. Still, SETI teams searched for technology. That was not irrational. A rare interstellar visitor is exactly the kind of target worth checking, even when it looks natural. The Allen telescope array searched between 1 and 9 gigahertz for more than 7 hours. It began with roughly 74 million raw detections. After filtering, around 200 candidates remained. Everyone was traced to human-made interference. FAST, Meerkat, and the Green Bank telescope also found no credible narrowband signal. Some searches were sensitive enough to rule out transmitters with powers comparable to ordinary household electronics in the observed frequency bands. But no signal does not mean no technology. It means no detectable signal of the tested type at the tested frequency during the tested time. That limitation reveals the deepest problem with the alien hypothesis. A specific claim can be tested. If someone claims that 3I/Atlas is transmitting a narrowband signal between 1 and 9 gigahertz, telescopes can look for it. They looked. They found nothing credible. If someone claims that it accelerates without enough outgassing to explain the motion, astronomers can compare the acceleration with the observed gas production. Current observations support ordinary outgassing. But the broader statement, it could be hidden alien technology, can survive almost any result. No radio signal. Perhaps it is silent. A normal coma. Perhaps the coma is camouflage. Natural molecules. Perhaps the machine is covered in ice. No maneuver. Perhaps it chose not to maneuver. A hypothesis that can explain every possible observation predicts nothing specific. That does not make alien technology impossible. It makes the unrestricted version scientifically weak. The argument even reached Washington. On July 31st, 2025, Representative Anna Paulina Luna wrote to NASA's acting administrator. She asked whether the Juno spacecraft had enough remaining fuel to investigate 3I/Atlas near Jupiter. One proposed intercept required a velocity change of roughly 2.68 kilometers per second. The intercept did not happen, but the letter did not declare the object alien. It argued that a visitor passing only once might justify an unusual mission opportunity. And that is the fairest way to understand this entire controversy. Loeb was right that rare objects deserve aggressive observation. He was right that uncertain size estimates and unusual trajectories should be examined rather than dismissed. He was right that SETI searches were worth doing. But the leap from unusual to technological remains unsupported. Every major positive observation currently fits one coherent natural picture. An icy body formed in a planetary system unlike ours. Something ejected it into interstellar space. It traveled through the galaxy for an unknown length of time. Then it crossed our solar system, warmed and released molecules preserved from its place of origin. So the most extraordinary possibility may not be that 3I/Atlas is a machine. It may be that it is a surviving fragment of the early Milky Way. A piece of ice and carbon potentially older than the sun, entering our neighborhood once, revealing its chemistry, and disappearing forever. The question is not whether scientists should be allowed to ask if it is technology. They should. The question is what evidence should be required before that possibility becomes an explanation. Should one unusual feature be enough, or should artificial origin remain the last option, after nature has failed? Tell me where you would draw that line. And subscribe if you want more scientific arguments where the strange answer is not always the alien one.